Okay, so let's start introducing ourselves. I will start. I'm Sara Petti. I'm the community manager of Frictionless Data. I'm based in Bologna, Italy, famous for its pasta and its ragu. I'm really happy to be here with you today. It's the last call of the year. Just a little reminder that we at Open Knowledge Foundation will be shut from the 20th of December to the 3rd of January. So if we're slow in replying also on the Discord forum, just be patient. We'll be back to you next year. And I will pick someone else to go ahead with the presentation. And I pick Melvin. Do you want to go next? Oh, we can't hear you. Very low, but yes.
Yeah, my name is Melvin Ochieng, and I'm a Frictionless Fellow for 2021-2022. My mentor is here, Lily Winfrey. Yeah, and I'm excited to join this call today. So I'll pick on Lily.
Thanks, Melvin. It's nice to see you today. I'm Lily, and I'm the product owner for Frictionless Data, and I am in unseasonably warm Austin, Texas. So yeah, and it's morning, and I'm just really excited to talk to everybody today and have a lot of like end of the year good feelings. So hopefully I can share those feelings with you all. And I will pick Augusto, please.
Thank you, Lily. Hello, everyone. My name is Augusto. I have a long history with Open Data and the Open Knowledge Foundation. I have been using Frictionless Data for some years now, and usually try to contribute to the Frictionless community. And I work currently as a data engineer in the Ministry of Economy in Brazil. I'm based in Brazil. And I'm especially excited about the subject today because DAGs is what I work daily with in Apache Airflow. So I'm curious to see what we will discuss today about using Frictionless in DAGs. We do use Frictionless in DAGs to create some data packages for open data. So I can even send you a link in the chats if you want to check it out. So who do I pick next? Edgar. Bom dia, Edgar.
Thank you, Augusto. Hi, I'm Edgar. I'm Brazilian developer, but working for Open Knowledge and just joined Frictionless Data a few time ago. And I'm based in Rapallo, a small town in Liguria, in Italy. And yeah, I'm pick another person. So it's pretty good. Logan?
Uh-oh.
Hi, Logan.
I just joined.
Welcome. We're just doing a round of introductions.
Oh,
welcome.
Everyone. I'm Logan Byers. I work at the World Resources Institute. Oh, hi, Caitlin. I work at the World Resources Institute, and I work on open data and technology, including how we research data and publish data. Nice to be here.
Can you pick another person? Yes.
I apologize. I just joined, so I don't know who has gone. If somebody would raise their hand, perhaps, or I see Ayrton.
Oh, yes, Ayrton. Hi, everyone. I'm a PhD student at UCL, and I'm currently working on a number of open data projects and open source projects around energy data. So I'll also be interested to chat with you after this, Logan. But I'll hand over to Caitlin.
Sure. Hi, everyone. I'm Caitlin Augustine. I am involved in the Data for Good community and got a recommendation to learn a little bit more about frictionless data and see how how we could bring more volunteers into the space.
Do you want to pick someone else, Caitlin? Sorry.
Oh, yep. And then I'll hand it over. Did Edgar already go?
Yeah, I think we're just missing Taras, Afzal, and I propose that Keith goes last as he will present them directly.
I'll hand it over to Taras.
I just texted my info. Hi guys, so I mainly work on custom data visualization tools for VS Code IDE. Some of you might have seen them, I don't know. I'm interested in your technologies because I like the data package and table schema that I'm looking to integrate into the table viewer I'm working on this month. That's it.
Thanks, Taras. Afzal, do you want to go next with the introduction?
Oh, I don't know.
I think we're just missing Afzal.
Hi, everyone.
Okay, Afzal?
Yep. Hi, hello, everyone. I'm Afzal Ansari. I am currently working for one of the organizations based in Cloud Native. But yeah, based on my interest, I am here to learn more. First, all about Frictionless, and I'm currently based in India. So I'm interested in let's have it. Some clean insights for you. Thank you.
Afzal, sorry, you were breaking a little bit. Would you mind writing also in the chat?
Okay, all right. I will do that.
Thanks so much. Keith, after you. The show is yours now.
Hey, hello everyone. Thank you for joining on this Friday so close to the end of the year. So my name is Keith Hewitt. I'm a postdoc at NIH and NCI, and I have kind of research interests and projects having to do with precision medicine and large-scale data integration. And the data integration is kind of what brought me to Frictionless some time ago. And got me interested in kind of how the specs that Frictionless puts out and the tooling can be used to facilitate that process and make it much smoother, ultimately allowing us to kind of answer questions much more quickly. All right, with that, I'll get started. I'll share my screen in a second. All right, can everyone see my screen?
Yes.
Okay, so first off, let me just say that today's talk is kind of something like a brainstorming session in the sense that a lot of the ideas that I'm going to share are things that I'm really excited about and think could have potential. But they're all things that I've been kind of formulating over the past few weeks. And so I think there's also a lot of room for kind of improvement and fleshing things out. And that's kind of the motivation to share it, is that even though I'm excited about some of the ideas I have, I know for a fact that the best formulation of any of this is not going to come from my mind alone. And that the more kind of different perspectives I get, the better it'll be. Okay. So the basic idea that I want to present is to embed an annotated data provenance DAG in the data package JSON file. I'm going to talk about why I think that's a useful thing to do, or it could be a useful thing, and how we might approach this, and then kind of what a future could look like with data repositories interacting with these. But just keep this in mind as like kind of the big picture of what I'm going to talk about, or to give you something to kind of work off of. The basic idea is, yeah, revolving around using some of the frictionless specs to encode the data provenance or data history. I think most of you are probably familiar with directed acyclic graphs, or DAGs, but just to be sure, briefly, DAGs are basically just directed networks that don't have cycles. So yeah, whenever you have a network, it can be undirected or directed. When you see an arrow, it means directed, so that the kind of movement goes in a specific direction and not back the other way. And a cycle just means that you can't do like A, C, D, and then up to B and back to A. So here, if you go down any path, you can't get back to where you started. And these are represented as sets of nodes and edges. Nodes you'll sometimes see referred to as vertices, and then edges as links. And there's some other terminology, but those are the common ones. Okay, I figured to kind of make it easier to get started, I would just start with a demo to give you a sense for what I'm thinking about. Again, the demo is very basic because it's all been done recently, but hopefully it'll give you a sense of what I'm imagining. So what this is, or what I'm about to show you is just a React simple web app. And all it's doing is it's loading one of the data packages generated in this flow and then kind of visualizing it. So the way I think about this kind of in terms of the end goals a lot is imagining what a dataset landing page could look like on a hypothetical kind of data repository. And so that's kind of what this is depicted as. And so what you're seeing is for a single data package that represents kind of the end point of a data pipeline, you're seeing kind of what the landing page could look like. So on the left side, it would be kind of typical information. This is all pulled from the metadata in the data package .json file, but just the data set ID, the title, kind of where it came from. Eventually, I want to encode things like the number of rows and some summary statistics that are generally useful. But for now, just like columns and version description. And then you can imagine including citations, and also download links would be a good thing to put here, linking out to something like Zenodo, perhaps. The middle is where views will go. And so this was actually one of the things that I got really excited about this idea is that, and this is something that Rufus actually, I think, has been thinking about much earlier, and I only just became kind of aware of, which is the idea of encoding views of data within the JSON files. And I think that's actually can be quite powerful. But this is just a view pulled directly from the data package file, and in this case showing a PCA plot for the data set, comparing the samples. And then finally on the right side in the third column is the actual DAG. So here, kind of right now, the nodes are labeled in terms of the actions, which should probably be changed so that the nodes would be, since they each represent like a stage of the data in the processing flow, they should be given a name like, initial, normalized, and so on. And then the edges should be the actions. But yeah, so download, reprocess, and collapse multi-entry genes. So this is a simple kind of data processing flow that I'm going to work with throughout this kind of today to share some of the ideas. So this is what gets rendered. So where is this actually coming from? So actually, I'll show you here. So what I did is I have a computational kind of pipeline set up using something called SnakeMake. SnakeMake is something that's pretty widely used in the bioinformatics community. It's kind of modeled after Makefile, but allows you to mix in Python and then call out to other things like R or Julia or whatever you want to. So it's a nice way to just stitch together lots of different components very kind of naturally. The goal is not to tie any of this to any specific kind of pipeline framework or programming language. So I'm trying to do everything as agnostically as possible, because I think the more important idea is not the technology, but kind of what's being conveyed. Okay, so here you're seeing directories with outputted kind of stages of the data. The cache one's not important. That's just used for some of the libraries as it's downloading the data to cache kind of versions of it. But the three kind of stages in the pipeline are, actually here, start with the pipeline itself. So I mentioned there's a snake file that's kind of like a make file. All the important thing I'll just point out here is that the rules represent different stages of processing. And so the three stages are downloading the data, normalizing it, and then finalizing it. And then in each of these, generating kind of a data, a row and column metadata, and then a data package.json file. And so this is kind of one of the basic ideas, is that it would require adapting kind of computational pipelines to generate intermediate data packages representing each node in the DAG. And I think takes some extra work, but there's a benefit in that things become much more transparent and easily to convey. So what do those data packages actually look like? So if we go, oops, original. This one. So for those of you who work with data package, it should look pretty familiar. Nothing too exciting. The resources again are data, row metadata, and column metadata. Oops. And then here I have this kind of custom section where I'm adding some annotations that I think are generally useful for things like rendering on a web UI and kind of passing along to different pipeline components. But what's relevant for today's talk, or what's most relevant, is this section. So here there's a provenance block, and then within it there's kind of nodes and edges. In the original one, there's only a single node because this is kind of the starting point. And so it just encodes some information. It has an ID, describes what's been done, where it came from, and so on. And then the actual pipeline, or I wrote kind of a short API in R and in Python, and these will kind of embed their own tags of their versions, so you can keep track of that as well. And at the start, there's no edges. It's just a single node in the DAG. And then we can imagine looking at a later version of this. So that was the original one. Let's do the next step is normalized. And so I'm just printing out that provenance block now. And you can see the original node is here. This is what we saw before, just formatted a little differently. The second step is now added as a node. And now you have an edge going from the first one to the second one. And then you can do the same thing for the third step. Oops. Call the final, and then again, there's another node added and another edge added. And so that's kind of what gives us this simple DAG we're seeing here, where you go from download data to reprocess to collapse multi-entry. And again, as far as directed acyclic graphs go, this is not the most exciting. This is kind of a trivial case, but I think this will hopefully convey kind of some of what I think the potential is. Okay, so now with that kind of background, I think I'll continue with the presentation, and then we can kind of return to other aspects of the kind of actual code and metadata later. I think it'd be helpful first to talk a little bit about what kind of motivated me to think about this in the first place and why I got excited about it. So for those of you who happen to be here like a little over a year ago, I gave a presentation on a different but related idea, which was creatively named BioDat, and had basically had to do with kind of curating bio data and making it easier to integrate data by kind of standardizing some fields, adopting a metadata format within data package so that things would be conveyed in a very clear way, and then kind of building some modular pipeline components around that for exploratory data analysis, normalization, transformations, all those kinds of things that one would typically want to do. And yeah, again, the big motivation there, the original motivation was just to make it easier to integrate data sets. And if you go through the effort to curate data once, then you could kind of share it with other people and save them a lot of trouble to quickly pick it up and work with it. More recently, I've realized that there's no reason to make this biospecific, and that a lot of the kind of ideas could easily be generalized and potentially benefit a wider community. And so I started to think about that and kind of work in that direction. And then, yeah, there's still like, even if there's this generalized kind of pipeline environment, there could still be domain-specific applications, because there are some things that you would only want to do with bio or genomics data or other types of data, and that's okay too. In this kind of project, I already was thinking about provenance and kind of encoding this in the metadata, but this was done in a linear form. So I had in kind of all the data sets I was processing and generating in this kind of framework, I had a provenance block with linear entries depicting each of the steps. So typically what would happen is the data set would get pulled. There's something called a recipe, which brings the data from some source into the kind of data package. And then it would get passed along to a series of pipelines to do different things. And then each of the pipelines would kind of tag or add its own kind of tag to the provenance section describing what the pipeline step was, maybe what parameters were used and things like that, and then when it was run and what versions. And this was, again, just to make it kind of more clear what exactly has happened to the data. But there's a problem, I mean, among other things, but this doesn't work so well when you imagine now having two data sets you combine into create a new one. This kind of linear form doesn't really capture that very well. And so this is where I started to think about how DAGs could be actually useful, not just for this kind of provenance in the metadata, but more generally just to accurately capture all the kind of details that go into a data processing flows. So yeah, DAGs are already used a ton in kind of data-oriented and software tasks. So one example is computational pipeline frameworks. So this is an example from SnakeMake, but many of the other pipeline frameworks, Luigi and Xfloat, all very likely use similar kinds of data structures under the hood to handle dependencies of pipeline steps. And similarly, so package management and software management environments that kind of deal with dependency management, such as kind of Linux or homebrew package management. Conda is one that I use a lot that has package management that can be incredibly slow sometimes, but they're also dealing with a very challenging problem and do a lot of great work. So, but yeah, so DAGs are used in this case. The one that's probably excited me the most recently is the use of DAGs in causal inference and causal modeling. So causal modeling is basically an effort to kind of frame problems or think about kind of like science models before you even do any statistical modeling, to think about like, what are all your variables? How are they related to each other? And then try to consider alternative hypotheses and then explicitly depict these in a DAG form. So for instance, let's say you're interested, and this is just pulled from a recent paper in kind of pediatric studies, but if you're interested in kind of the impact of screen time on obesity, you could think about this kind of causal relationship here. But then, you know, there might be other things that are kind of mediating this interaction, such as physical activity. So screen time affects physical activity, which in turn affects obesity. But then you can kind of, as you think about this more thoroughly, you can kind of imagine other ways that this kind of causal structure can play out. And so causal inference is kind of all about understanding these kinds of relationships and then using them to kind of constrict what statistical models you end up adopting and to try to inform kind of essentially what approach makes sense. And ultimately to incorporate rigorously causality into scientific modeling, which is not always the case. But what I think I really like about this, or what kind of excited me about this, is the fact that there's a big emphasis on making uncertainty explicit. So there's a lot of focus on things like missing data and confounders and kind of explicitly depicting those. And I think that's something that could be really useful to try to incorporate into data processing flows. So, okay, that said, here is the big picture of where I think this could go and why I found this exciting. So my premise is that we understand data far less than we think we do. What I mean by that is the current approach to data processing looks something like this. You start with some raw data and you process it and you get clean data. So this is typically done by someone referred to as an expert, be it a PhD student, a postdoc, or a data scientist. And then if you're considering this in the context of science, typically this would lead to a publication. Hopefully, maybe published to a data repository as well, instead of just like an Excel spreadsheet with the publication. And then, you know, if you're fortunate, they'll also be thoughtful enough to put the raw data in the data repository as well. So there's kind of a more transparent record and empower people to kind of do the processing themselves. Whether people publish the code to do the data analysis with the publication, that's increasingly happening, but still quite uncommon overall, at least in a lot of the fields I've looked at. The bar is pretty low when it comes to publishing. Hopefully that'll change. But there's some problems with this. The big one that I think this whole effort could potentially assist with is that there's a whole lot of stuff that happens here that isn't really captured in a publication or even in the code that when you publish it. And what I mean by this is that data processing is kind of challenging and not obvious. There's no one way to like do it. That's always obvious, right? There's a lot of decisions that have to be made along the way, and often a lot of like weird and unexpected things that come up. And the people who work with the data and who have kind of training and understanding of the nature of the data, they'll make decisions, you know, based on good reasoning and justifications, and sometimes some kind of exploratory analyses and things like that. That kind of decision making and even those kind of exploratory plots and things like that are seldom included in the publication or, you know, published in some kind of public and transparent way. And so that kind of knowledge gets lost, and we just end up seeing the clean data and we kind of forget all the assumptions and things that went into it. So yeah, what we get at the end of the day is not so much the best way to process or analyze some data set, which is kind of what we think of when we think of like clean data, but instead what we get really is what one person with their own particular perspective, skill set, understanding, reasoning, and so on thought was the best way to process the data. Just to elaborate a little more on the problems, experts are humans with limited knowledge and specific experiences. So, you know, I consider myself to be quite knowledgeable in the kinds of data that I work with, and I at least try to put in a lot of time to understand things and read and, you know, test my knowledge. But still, you know, there's a lot I don't know. And so my own kind of interpretation of it is going to be biased on just the experiences and kind of what I do know. I think the kind of the framing and expectation that there is a single best version of the data is wrong. So this is, again, like thinking in the context of science, where you often have an advisor that hands some kind of raw data off to a student and says, you know, process this so we can answer this question. There's kind of this implicit assumption that there is a way to process the data optimally. And I think that's just not really a great way to frame it. And that really, there's potentially many different ways you could try to process data to answer different questions that are all potentially useful. Data processing and analysis is like an art. So like I said, there's just a lot of decisions that typically get made along the way that there's no obvious right or wrong choice. If you were to give the same raw data to 10 experts, I think very often you would end up getting 10 different results back. And then, yeah, again, a lot of information is lost when you just present this kind of static slice of the clean data at the end. Context, assumptions, reasoning, and so on. And then finally, so I think one of the big problems in all of this is, again, that not always, but very often you have individuals who are going through this process, right? There certainly are cases where there are companies who have teams of people who sit down and collectively try to work through these problems together. But very often it's something more like an advisor handing a data set off to their student or postdoc, or even in companies, you have someone who's paid, you know, they're hired as a data scientist or a data engineer or whatever, and they're given some data set and some problem and kind of expected to just know how to do it themselves or figure it out. And when you do have multiple people working together to analyze the same data set, unfortunately, it tends to be done independently. So I'm thinking of examples where There might be some kind of high quality data set that's published online, that was collected by multiple institutions and costs a lot of money. And then you have lots of individuals in different universities and companies and whatever downloading the data and then independently trying to go through the same processing and spending many, many hours coming and each kind of ending up with their own interpretation of it. So yeah, there's a lot of redundancy and just kind of lost missing shared insights, I would say. It's kind of related to problems in science publishing and kind of the static nature of that, but we'll save that for another day. Okay, so what I think would be a better approach, and where I think this whole kind of idea of encoding the data processing flow in a DAG could be a step in the right direction, is it would be good to shift from this focus on the single static data sets, the kind of processed or clean version, to thinking of it more like a collaborative, evolving data workflow. So the initial data processing attempt you treat more like a first stab. So even if you're doing it on your own, you kind of publish it, on GitHub or out in the open, and then other people could come and kind of improve on it. So basically, if there is data that there's more than just one person who cares about that data, which is often the case, I think there is a community that is interested in different types of data, then they can kind of collectively work on it and kind of iteratively improve the processing of the data. And then the big kind of motivation or intuition is that the more perspectives we can involve in the data processing flow and understanding the decisions being made at each step, the better chance we have of ultimately understanding the data in the end. So the DataDag, which again is just kind of a tentative name I'm using to refer to this idea, but why I think it's useful is because I think it could be a potential mechanism through which this kind of collaboration could take place. And it's an effort to make all the assumptions, reasoning, uncertainty that goes into data processing much more explicit and transparent, so that we have a better understanding, not only of what we think we know, which is kind of the emphasis in science publishing. You kind of take this whole messy data processing flow and you distill it out and kind of sweep a lot of the uncertainty under the rug and present this nice, like clean linear story. That's our understanding. But I think as important, or maybe even more important sometimes, is it would be good to know just how much we don't know and how much uncertainty is going into this data processing flow, and just make it more obvious. So the basic idea, encode the data provenance in the DAG and the metadata. For each step in the data processing workflow, you take the previous DAG, read it in, and then add a node and an edge. It's pretty straightforward. I would try and have already started, but basically create APIs in different languages to facilitate this process of kind of reading the DAG and updating it and kind of working with the data packages. Each node in the DAG represents a data set at a particular stage of processing. And then each node can be associated with one or more of the following. So annotations, which could be markdown notes on processing logic, assumptions, caveats, and so on. So these are the kinds of things, if you think about, like, as you are analyzing data yourself, you might kind of notice some things with the data, like outliers, or just have questions about it. And you might keep a note of that to yourself somewhere, or maybe write a comment in the code. But I think those are the kinds of things, like this kind of interpretation that's going on and that doesn't really get included in the publication necessarily, are still really useful to try to capture. Because often, like, the people who are working with the data, they have these questions and they have these ideas for good reasons. So it would be good to kind of save these and allow other people to use them and kind of get a grasp of how people are thinking about the data. The other thing that could be incorporated and associated with each node are one or more views. And so views in this case refers to just plots that are encoded in Vega Lite JSON. And this could be used to basically like motivate this reasoning. So as you imagine kind of processing the data and taking it from stage A to B to C and so on, often you're transforming the data or filtering the data or modifying it for a particular reason. And more than just write a sentence in the paper saying we normalize it this way, it would be nice to say, we normalize it this way, here's a visualization of it before and after, and kind of this is why. Or in cases where there's like outliers that you're filtering out or things like that you're dealing with, you could actually visualize those explicitly and encode this in the data processing flow so that someone else could pick up this kind of data package and see like, oh yeah, this is what the user was referring to when they made this decision to filter, and that makes sense, or it doesn't make sense. So data packages would be generated associated with each node. And I'll talk about a variation of this idea towards the end that I think is also interesting to think about. But for now, just assume that, yeah, each node is associated with a separate data package that includes the data for that node, and then kind of the DAG representing everything that came before it. And then finally, it'll be useful to have a web UI that can read the metadata and then render the DAG and some other stuff. And that's kind of what I showed you in the demo earlier in a very simple form. So what that overall process would look like in practice, you would have a GitHub repo with your pipeline. So here in this kind of toy example, there's only 2 steps in the pipeline. The first one and second one each have a separate script associated with them. You could have an annotation, a markdown file essentially with notes depicting kind of decision making and just things to look out for in each of these steps. And then finally, you could have different types of views that you incorporate with each of the steps as well. And a recipe.json file is just some metadata that would include that would facilitate any kind of tooling to understand and generate these DAGs. I can maybe share that later. But yeah, so this would get run and would generate data, 2 data packages in this case, which can then be published to Zenodo. And then finally, you could imagine having a web UI, which can kind of load these JSON files, and you don't even need the data, which is one of the nice things. Like, especially in this case, I mean, the PCA plot data is separate from the data package, so you would have to pull that. But if you're generating views like this, it's potentially small enough where you could even embed the data for the views directly in the data package so that you'd have a single file that could be read by like a web UI or command line UI or whatever, and then kind of lots of useful things pulled from it. Okay, so one of the big questions that I've been thinking about is, should the data package represent a single data set or kind of all stages? So initially, as I was thinking about this and kind of what I've described thus far, the kind of focus is on single processing stage, which is that the data package that you look at only includes the data for a single stage of the processing. It still includes the DAG for all the steps leading up to it. And then also the views and annotations are kind of limited to the current stage of processing. So if you're imagining looking at the final version of the data or whatever, you would have the final version of the data, the annotations and views for that specific stage, and then you would have kind of a DAG just referencing the IDs of all the stages that came before it and kind of some basic metadata. But what you wouldn't have is the data for the previous steps, and you wouldn't have the views and annotations for the previous steps. There are other ways you could think about framing this that could potentially be useful. Another one is to basically start from this point, but then in addition to including the kind of the DAG and the metadata, also include the views and the annotations for all nodes. The motivation here being that, typically the annotations and views, are marked down in kind of JSON. They're not very large, so the cost of including them would be quite small overall. And the result is that if someone downloads the final form of the data, they would have not just kind of the data and annotations and views associated with that stage of processing, but they would have kind of the kind of visualizations associated with all, and the kind of reasoning associated with all the previous steps. So I think that's potentially useful. Still lightweight. And then, yeah, you could essentially pull the actual data for other stages in the DAG as needed or as desired. And then finally, there's kind of a third version of this, which is same thing, but then include the data as well. So views, annotations, and data. And this is probably only practical for smaller data sets, because if you have a large kind of data processing pipeline, you might have many stages, and then, you know, collectively the data sets would all add up to a lot and be kind of bulky to pass around. But in reality, I mean, there are some data sets that are really small. And the nice thing about this is that it's portable and self-documenting, so that you'd have a single data package that represents the data at every stage in processing and kind of all the decision-making and logic that went into each of the stages, kind of visual, EDA, and so on. So it's highly portable and self-documenting. Okay, limitations overall. These are just a few examples, but first one is bookkeeping. It takes some effort to kind of modify pipeline codes to read in the DAG and update it and then write it back out. I don't think this is that bad, to be honest, just in my own experience of working on, trying to move my pipelines over to this framework already. And I think there's room for some kind of libraries to assist in this process and make it even easier for users to kind of generate and update the DAG. But it's something to think about. So far, the focus is on tabular data. I think ultimately it's interesting to think about other types of data and how this could be used for that. But at least initially, I'm just, focusing on a simple case of tabular data. And then there's a question of scalability. So, I mean, I've showed toy examples with just a few stages, and it's easy to visualize. In moderate data processing flow, where you might have, a handful or tens of steps, I think the DAG depiction could work fine. When you start to get to much, much larger data processing flows and think about like how to visualize that, it becomes a little trickier. And then if you think about some of the other ideas I'll talk about in a moment, where you might imagine like forking the DAGs and creating alternate versions, and then how you depict the relationship between them, it could also become challenging. But I don't think any of these are kind of showstoppers per se, just things to be aware of. Okay, and then one of the last things I want to talk about is basically an idea for where this could go in the future and what I think is exciting. So one of the ones that I alluded to earlier on when I was talking about kind of causal inference is this idea of visualizing uncertainty. So I think maybe for, I'll pull up the webpage again in a moment, but actually, I'll do it now. So here's a DAG. Right now, the nodes are only being colored to highlight kind of what's currently visualized. So this is kind of the node that's being depicted here in terms of the views and metadata and so on. Eventually, one would ideally want to make this navigable, so you could click on the different nodes and go to the dataset landing page at the different stages of processing. But you could also imagine encoding other types of information in this DAG, right? So like for visualizing uncertainty, for instance, you could imagine changing the color or opacity of each of the nodes in proportion to the amount of missing data or imputed data to kind of transparently indicate where those are and how it's changing across the data processing flow. So encoding other types of information, you could also imagine like essentially having different colors assigned to different types of operations. So like filtering, or if you have operations that are kind of more continuous or discrete in how they're interacting with the data. One could imagine conveying the variance of the data as it changes across the data processing flow, because this is something sometimes we'll transform the data in a way thinking it's helping us, and we end up, losing a lot of the information or the variance in the data. And I think if you were to kind of visualize, color all the nodes by variance, or have the option to kind of toggle between these different layers of information, then one could kind of see much more clearly. It could also be interesting to think about like, demographic information. So for instance, in a lot of the genomics data that I work with, there's kind of the goals are to develop treatments to help the population, right? And so the population is very diverse. The data sets that are used are often not. And I think making that much more transparent can be a good thing. And then also if you have like filtering steps where you're removing, patients or observations from the data, it would be good to know if you're removing things in a biased way such that you're affecting certain populations more than other. Okay, and then last couple things. If you were to imagine having, so the whole motivation again for all this is that by encoding all this in the in the metadata file, you could put all this on GitHub, right? So the data pipeline could go on GitHub, but also the generated, the metadata files could go on GitHub. And then someone could essentially fork the repo and then create their own variations of it if they disagree with you. And then if you would imagine a repository that interfaces with kind of different versions of a data processing flow, you could think about users essentially voting on which versions of it they think are the most useful, or voting on different steps within a single processing flow, or voting on different views and so on. I think there's a lot of potential there. If you've ever used Kaggle, they have something called Kaggle code. It used to be Kaggle kernels, but it's basically just a way that for the prepackaged data sets that they have, people can submit notebooks, and then the community can vote on which notebooks are the most useful. And I think that's incredibly useful and missing from pretty much everywhere else in science. If you have data that's now in this kind of nice data package format where someone could download it and very easily start working with it, it would be really useful to provide a means where they could share basically their own explorations of the data and point out interesting things they're finding in a format like a notebook or a data sketch. And I think for time, I'll just skip this, but it's also interesting to think about. So this is using the DAG in one way. One could think about kind of recursing in either direction and think about like if you have, if you have different kind of forked versions of it, you could depict those kind of different versions as a DAG, so a DAG of the DAGs. And then you could go inside as well and think about each node is a data set. It represents a collection of variables, and then you could think about like depicting the relationship between those variables using a causal model or probabilistic graphical model. And that's pretty much it.
Yeah, Keith, sorry if I interrupt you, but maybe we want to allow some time for questions.
I think so. I'm going to stop sharing. Thank you all for listening.
Thanks very much. That was definitely very interesting, and I'm sure that there's a lot of questions. That's why I wanted to give time for people to react. Does anyone have questions? I know that we already had a couple in the chat. So Ayrton had a question.
Sure.
Oh yeah, so my question was basically around, you mentioned right at the beginning about some row level metadata. And so I was interested in sort of why you were adding that and how you're specifying that within the schema.
Yeah, okay, so that is kind of related to the separate effort that I had mentioned, the biodat thing. So I can perhaps present on that another day because it's also, I think, interesting in its own right. But this is basically the way I think about a lot of what would be a useful way to represent data is kind of this data model where you have a data set and then kind of row and column metadata. And if I package up data in this way, I think it kind of includes a lot of the useful information that you can then start to envision writing very generic pipeline steps that can read in these data and know exactly where to find the things they need to, visualize it and transform it in certain ways. I think it would probably be best maybe if we talk about that offline or share it in a little more detail, because again, there's a lot of thought that went into that as well, and it'd be hard to kind of justify right here. But yeah, so that you can, I guess I should say that the DataDag doesn't depend on that kind of use of row or column metadata or that kind of formulation of a data model. That's a separate thing. And I tried to detach them. But I think as I was porting my own pipeline code, I kind of ended up inadvertently mixing them back together. Okay, good question though.
I see, Logan, that you have your hands raised, but just 1 second, because Taras had a question in the chat before.
Oh yeah. So my question is the Actually, I have two questions. One, the React app that you showed, is there like a repository I can clone and run it? I'm interested in the setup of the sample data that you had there.
Yeah, absolutely. I haven't set up a repository yet. Because I haven't really decided a name, but I can do that and I can share it with you. If you want, maybe you can ping me in Discord or the chat or otherwise with your email and I can share it. I mean, all of this I plan to do openly. The only reason I haven't shared it is just because it's kind of in a prototype form and not really, I would say, so much useful as beyond demonstration.
That's cool. No, I find it interesting from the constructing data parts point. The other question I had, you mentioned views for DAGs.
Yep.
And are you suggesting that you would be using something like resources and views would be like Vega light specs would be the files that are referenced from the data package or in
Yeah, exactly. So I didn't get to, or I kind of forgot to show this, but the way I incorporate it now is I actually have the views as separate JSON files. I think that's nice just for GitHub to make it easier to kind of keep them separate so you don't have to edit one massive data package file. And then what happens is as the pipelines run, the views get read in and the annotations as well. They're separate markdown files. Those get read in and embedded in the data package so that when you actually share the data package, it's portable and it has all the views and annotations encoded. But in the kind of the GitHub pipeline format where you're actually creating the views and writing the annotations, it's completely separated.
That's perfect. Thank you.
Yeah.
Logan, do you want to go ahead with your question?
Yeah. Thank you. It's going to be hard to mask my enthusiasm for this because I think it's really fantastic and you've really thought through a lot of problems. So I think there's also a massive need for this sort of stuff. So I gotta maybe just going to talk around some areas really quickly. One is just like provenance ontologies do exist. And I know that working with RDF things isn't the easiest always. It's not the cleanest. And I think that's why probably a lot of us like Frictionless. It's very easy just to like work with.
Yeah.
So do you feel any opportunities for interoperation there, I guess, is kind of one question. The other one is just very quickly is maybe, are you, let's just leave that one. I'll just leave that one. That's the only one.
Okay. Yeah, no, that's a great suggestion. I would say I don't know enough is the answer, to be honest. Like I've been thinking about data provenance for a long time, as long as I've been working with data, so, many, many years, but there's I incorporate ontologies and control vocabularies into other efforts as I'm trying to curate the kind of biodata, but I haven't thought about it so much with respect to the provenance. I think that's a fantastic idea and something I should learn more about. The one caveat I would say with how I think about all this and my kind of experience in interacting with these kinds of efforts in the past is that I noticed there's a potential to basically get bogged down in the details, and that like describing data is really challenging and doing a way that everyone can agree on is basically impossible. And so my goal is I would love to use the kind of ontologies and control vocabulary as much as they can facilitate the effort. But if it comes to the fact where you can't ever satisfy anyone, then just make a pragmatic decision and kind of use the things that are good and, evolve the rest as time goes on and you kind of understand. Good question.
Okay, I see that Lily and Augusto have both their hands up, but I want to be mindful of time. So I wanted to ask everybody if it's fine for everyone here that we go 5 minutes over. Also for you, Keith, of course, if you can keep answering questions.
And anyone, feel free to leave if you have obligations and things like that. Thank you all for staying through this and asking questions. I appreciate it.
Okay, so let's go on. Lily, do you want to go now?
Yes. This is awesome, Keith. Thanks for having these thoughts, but also for the presentation. I thought that it was very helpful, so thank you. I'm wondering if you've looked at LiveMark for the React app.
No, I'm trying to think, is LiveMark? I feel like that's the little badge you see in the bottom corner of some manuscripts or things like that. Or no, that's something else.
It's one of the frictionless tools that's been developed in the last 6 months or so. And it is a static site generator. And I think that it would be a great use case for this. You could just insert the data package and it uses Vega Lite. I'll follow up with you about that because I think there's some stuff we could do there.
Okay, I just dropped the link in the chat as well if you want to have a look.
That's it for me. Thanks again.
Gusto.
Hi, Keith.
Hey.
Thank you for the presentation. I think it was, gave me some food for thought. It was really interesting, this idea. I would like to double down on Lila's suggestions on LiveMark, especially for the views part that you mentioned, because it can be used to create this documentation that gets updated with the data. And you want to say something?
Oh, no, I was just going to say that's a good suggestion. The views are something I really only just became aware of recently through Frictionless. And that was kind of one of the things that got me really excited about this is the idea that you could take these things that are normally kind of awkward to convey in like, in science, for instance, you might have a supplemental file, PDF that's 40 pages long with tons of views, but no one's going to sift through those and try to understand every one. But if you have them in this much more natural form of the data processing DAG, and you're trying to understand some decision making, then that I think is a useful.
Yeah, another possible approach that I think many people could relate to and are used to is using, like for the processing steps, using Jupyter notebooks. They can be used in a plugin named JupyText. It can be saved as percent script, and it's useful because you not only do the data processing, but you can embed the visualizations and comments in an easy to read way. So that's another possible thing.
Yeah.
Want to go?
No. Oh, no.
And okay, go ahead.
No, please continue.
No, I just had another thought about this is the first time I heard of SnakeMake. It got me interested immediately because I work with daily with DAGs in Apache Airflow. But however, and I think that it's Apache Airflow makes something very well. That is when you have a lot of data pipelines. And each one has a different schedule and connect to different data sources. Apache Airflow manages that very well. You can visualize when each one is running, and if a specific task breaks, you can have the log of that task easily and debug it and get it running again. But Apache Airflow does not have a good handling of data provenance and which are the data inputs and outputs, and I see that SnakeMake does that very well. It just gave me an idea that perhaps a SnakeMake plugin for Apache Airflow could mix the best of both worlds, so we can track data provenance and at the same time have a good management of the all of your pipelines, see which ones are running when. So I think that could be something good. We in the ministry have hundreds of DAGs, data pipelines in DAGs already, and so data provenance, I think, something is not really a big concern, but I have always been interested in that, and I think it's very useful to document that, especially for people doing data analysis and for debugging and and I really like these ideas you mentioned as well about having notebooks right there for people to vote that Kaggle has, because often the data gets published but that still have some data quality problems, like for instance they have geographical latitude and longitude, and they get those swapped and in just a few lines of the table. Several. It's very common to have when you get a data set, you have to fix a lot of things. So if you can share that with the community, I think it's very valuable.
That's the big kind of thrust of this, is like this whole process of like generating the data, it happens opaquely and then gets published, and then kind of it sits there and it's done, right? But I think it would benefit from evolving, because people do have better understandings of the data and are able to come up with new insights and could potentially kind of continually improve the data processing flow over time. One could also think about it incorporating data versioning control as well. So something like DOF. And yeah, so you could have both the kind of the metadata versioned and kind of the pipeline code and all that, but also the data itself could be versioned and they could be linked together. But those are all great suggestions. And Airflow is something I've come across, but don't really know much about. So I'll have to look into it. And I'm happy to talk offline as well. Thank you.
Okay, thank you. I'll be happy to talk about it. You just can reach it out later.
Yeah. Any other questions?
I think that probably we have to cut it here, I guess, but we can keep on having a discussion if you want on Discord.
Yeah, I would say reach out on Discord, and if people are interested, we can chat in a separate channel or meet separately or so on. This is really just a starting point, the way I see it. So I'm trying to sketch out prototypes, but there's a long way to go. And if other people are excited, I'm happy to work with everyone on the different types of data that they're interested in and try to come up with a formulation that is beneficial to all and not just the kinds of ways I think about things.
Great. Before I let you leave, I have a few community announcements that I wanted to give you. So first of all is that our next community call is next year on the 27th of January, and we're going to have the hackathon team that won the Frictionless hackathon in October, and they worked on data package integration for CCAN. So that's going to happen next year. Meanwhile, for those of you who have winter breaks, I wish you very, very good breaks and great holidays. Another thing that I wanted to point out is that we are helping organizing a thematic track at FOSDEM about open research tools. The deadline was today, but it has actually been extended until the 23rd. So if any of you is interested in giving a talk there, it's a 20 minutes talk, more or less, and it's pre-recorded. So it's quite easy to do. It's on the 5th of February. I'll drop you the link in the chat if anyone is interested, and feel free to reach out if you need help to formulate a submission. The other thing that I wanted to announce that I already said in the beginning is that the Open Knowledge Foundation shuts down for the winter break from the 20th of December to the 3rd of January. So if you have questions, drop them in Discord, but we're only going to answer them next year. And I think that's it. Thanks to everyone for bearing with us after the hour. It was a very, very interesting discussion. Thanks again, Keith. It was great to have you here today. Yeah, Lily, do you want to add anything?
No, I think that's it. Yeah, happy holidays if you're celebrating, and see you in the new year.
Yeah.
Yeah, thank you all. Happy holidays.
Bye.
Happy holidays.
Thanks.
Nice meeting you
Bye.
guys.
Happy holidays. Thank you. Bye.